first of all, we're going to do a few loops, so that way we can do it without having to copy and paste stuff 10 times. Okay, so I'm going to declare all my variables up at the top. I'm going to declare an int I, an ns string, new text, and an ns calendar date, entry date. And I'm going to make new text, an ns string, init. And I'm going to make entry date, ns calendar date, calendar date. That's just going to get the current date. So wonderful, we have the current date and an empty ns string. So now we're going to do very basic steps to simply generate stuff and empty out the last set of entries. So we're going to say if not entries, with exclamation point entries, that means we've never said like entries is in fact an ns mutable array. So before you do anything with it, you have to set it to be an ns mutable array alloc init. So we're going to say if bang entries, that means it's not allocated or initialized. We're going to make a ns mutable array alloc init. That's pretty simple. And now we're going to say for I equals 0, I less than entries count I plus plus. We're going to do this. So this way, if we've run it previous times and entries was, for say, the last set of entries, we want to empty out all the entries within entries before continuing and adding stuff back in it. So first of all, an ns mutable array can contain a bunch of different types of objects. So there could be an ns string in it, and a lottery entry in it, and a app controller in it. You don't really know what's in it. So in this case, we know we're never going to add anything to it that's not a lottery entry, so it's easy to guess what anything in an entry is going to be. So we're going to say entry array, double left bracket, or entries, okay, object at index I, okay, space, deallocate. And the way this works is basically we're going to, object at index is going to tell us in return
It's 12 hours.
In this case, it's probably going to be an entry or a lottery entry. It's going to return the lottery entry at that place in the array. And then since every lottery entry has a deallocate method on it that we put here, you can just call deallocate. Now the compiler might not be happy that we're just assuming that the object at the index I of entries is going to be a lottery entry, and we can just get rid of that pain and suffering that we have to deal with a warning by doing left parenthesis lottery entry space star right parenthesis, and that's called casting. It tells the compiler that we know what this is going to be, so stop bugging us, basically. So now we're going to auto-release that after deallocating it, or we didn't really deallocate it, but we called deallocate on it. We're going to auto-release it, and that just means that it will go away and there's no way that it's going to leak. So now we're going to do entries remove all objects, all objects, and that'll just get rid of everything in entries for once and for all. So now we're going to generate 10 new entries. I'm going to say for I equals 0, I less than 10, I plus plus. And in here, we're going to do ns calendar date, last date equals entry date. So this way, we still have a pointer to the last entry date. And then we're going to say entry date. We're going to make entry date a whole new thing, and last date will be the only thing pointing to the old entry date. We're going to make it ns calendar date alloc, and it was year. We're going to make it last date, year of common era, last date, month, year, day, last date, day of month, hour, etc. And I guess you can probably get this at this point. Minute. And time zone is going to be nil. Okay, so this is a very wide function once again, so we can just new line it out here and make it beautiful and pretty. And there we go. So now it only fills up one screen. And now we're going to make a new lottery entry called LE. We're going to make it a lottery entry alloc Nick. And here we go. LE set date. And this is going to be the quite easy part. First number. Okay, so the first number is going to be a random number from 1 to 99. It's going to be a 2-digit number. So there's an easy way to generate a really long random number that might be 10 digits or something around that. So we're going to turn that into a 2-digit number. So first of all, there's a method or a function called arc4random that will randomize a totally random long number. And then there's a function called, or a modifier called mod, which is kind of like plus and divide and minus and subtract, except what it does is it gets the remainder. So if we do mod 99, it's going to be a number from 0 to 99. And if we want it from being from 1 to 100, instead of from 0 to 99, we're going to add another left parenthesis and we're going to add 1 to it. So this way we're making a totally random number that's between 1 and 99. So there we go. Now we're going to set that as the second parameter and the third parameter. And there we go. So once again, we will set up everything. So there. Now we're going to say entry array, or not entry array, entries, add object, LE. And there we go. Once again, so now we have an array that will have 10 items in it because this for loop runs 10 times with a bunch of lottery entries. So now we're going to finally display all the new lottery entries in the text box. So we're going to do another thing that goes 10 times, and instead of deallocating stuff in this array, we're going to display it in the text box. So I'm going to say lottery entry LE equals entries object at index I. And once again, because we don't want the compiler to complain to us, we're going to cast it with the lottery entry star. So we do left parenthesis, lottery entry, space star, right parenthesis. Okay, now we're going to do new text equals new text string by appending string, or not string, format. Okay, and then in here we're going to do %@\n, and here's going to be LE get string version. Okay, so I'm going to do cut here and watch part 3.